Assalamualaikum. First of all, my name is Nur Shazana Alia binti Ramzi and my metric number is 818290. So I will start the presentation with the data description. In this dataset, we have chosen 4 variables, which is liter per 100, KPL, weight, and brand. And in this dataset also, we have chosen randomly 150 from the SPSS. The measurement of these 4 variables, which is liter per 100, KPL and weight is a ratio measurement, while for the brand is a nominal measurement. And there is analysis that conducted in 4 variables. So that's all for data description.
Assalamualaikum, my name is Muhammad Zulkifli bin Sudirman and my matrix number is A21A2597. 2.0, which is a sampling data and recorded data. The table 1 shows that first and last 10 observations were chosen at random from 156 in dataset in SPSS. Okay, the next part, which is in table 2, show the descriptive variable that we chosen to conduct this case, which is a liter per 100, KPL, weight, and brand. This data was included in data given from SPSS system. The table on the right side is for the liter per 200, which we changed it from ungrouped data to group data. Both of table KPL1 and wedge was the frequency percent, valid percent cumulative that we changed from ungrouped data to group data from SPSS system. Last but not least was the table for brand 1 frequency percent, valid and cumulative from SPSS system. 3.0 numerical descriptive. 3.1 measure of central tendency. We use mean, median, and mode. The first one is mean for the liter per 200. This result show us the mean for the liter per 200 is 6.39. The next part is median. The median formula is n divided by 2. We get the 75 of observation. The class median is 4.84 until 6.40. Class with lower boundary is 4.34. C 6.9 minus 4.34, we get a 2.56. For the calculation, we get the median is 6.05. Thus, the median of the liter per 200 is 6.75. For the mode calculation, we use the class median is 4.84 until 6.40. Class with lower boundary is 4.34. Class 6.9 minus 4.34, we get 2.56. So the answer for the mode is the highest of the liter per 200 is 5.72. For 3.2 measure of position, we use frequency 150. Quartile calculation, we use quartile 1 and quartile 3. For the formula, quartile 1 is n divided by 4. We get the answer 37.5. The class interval is 4.84 until 6.4. For the quartile 3, we use the formula 3n divided by 4 and we get the answer 112.5. The class interval is which is 6.41 until 7.9. For the interquartile range, the formula is quartile 3 minus quartile 1. We get the answer is 1.96. Last but not least is 3.3 measure of variation. In this part, the measure of variation have two formula, which is a range and the standard deviation. For the formula, range is maximum data entry minus minimum data entry, and we get a 7.85. For the standard deviation, we get a 47.20.
Assalamualaikum warahmatullahi wabarakatuh. My name is Intan Nuraina binti Mama Hashim. and our metric is A21A2506. Now I will continue the presentation about graphical representation. In this part, our group choose to create a histogram and OGIF to show the data. For the histogram is referred as frequency distribution of dataset that was invested by the car person. And this histogram also referred as liter per 200. While for the OGIF is line graph where it displays the cumulative frequency. It was referred as a KPI1. But before we create the histogram and OGIF, we must first find the value of the lower boundaries, upper boundaries, midpoint frequency, and the value of the cumulative frequency. Then create it using that data. In conclusion, liter per 200 expectedly show car of various brands are less used for travel anymore, and for KPI1 show in about 140 km per liter travel distance have been passed by various types of car brands.
My name is Muhammad Irham bin Asri and my metric number is A21A2659. So for 5.1, this table shows the table of numerical descriptive measure of mean, median, mode, standard deviation, variance, range, and percentile by using SPSS and by calculating them manually. The result shows that the data from both tables is not same because the SPSS cannot read the data accurately. The table also shows that the manual calculations are much smaller than by using SPSS. Next, for 5.2, the hypothesis testing is a process to compare null hypotheses to see whether they should be rejected or not. And the null hypothesis is rejected when its probability falls below the predetermined significance level. And the table shows one sample test to define our hypothesis, and the other table shows ANOVA, the analysis of variance, a method to compare variance across means for additional tests, and it shows significance difference among the treatments.
Explanation for scatter plot. Label the horizontal axis of the graph as liter per 100 and the vertical axis as weight. As a consequence, we know the graph is presenting liter per 100 and weight data. A broad view of the scatter plot reveals that the data points tend to cluster in an upward motion from left to right. The growth is not remarkable, but there is a clear upward tendency. We must assert that the data are positively related since the scatter plot indicates an increase from left to right. As a result, we may draw the conclusion that liter per 100 and weight are positively correlated. Explanation of correlation analysis. The value of R between liter per 100 and weight is 0.716. Based on the correlation value, we can conclude that there is strong correlation between liter per 100 and weight. There is no significant correlation between liter per 100 and weight. Explanation of confidence interval 99%. The descriptive output table that our 99% confidence interval for the mean confidence in liter per 100 has been calculated. The lower bound is set at 6.0924 and the upper bound is set at 6.6625. The difference between upper bound and lower bound for the 9900 confidence interval for the mean confidence in liter per 100 is 0.5701. The 99% confidence interval for the mean confidence in weight has been calculated. The lower bound is set at 3.78324 and the upper bound is set at 3.9963. The difference between upper bound and lower bound for the 99% confidence interval for the mean confidence in weight is 0.21639. Explanation of confidence interval 95%. The descriptive output table that our 95% confidence interval for the mean confidence in liter per 100 has been calculated. The lower bound is set at 6.1616 and the upper bound is set at 6.5933. The differences between upper bounds and lower bounds for the 95% confidence interval for the mean confidence in liter per 100 is 0.4317. The 95% confidence interval for the mean confidence in weight has been calculated. The lower bound is set at 3.80950 and the upper bound is set at 3.97337. The difference between upper bounds and lower bounds for the 95% confidence interval for the mean confidence in weight is 0.16387.
Next, for the prediction modeling. For model summary, the R-square value is 0.505, which is 50.5% of the variation in brand 1, can be explained by the liter per 100, KPL, and weight. The adjust R-square value, which is 49.5%, and the Durbin-Watson is 2.023. The p-value from the ANOVA table is less than 0.001, which means that at least one of the three variables, which is liter per 100, KPL, and weight, that can be used to be a model brand. Lastly, for the coefficient table, the p-value between the liter per 100 and KPL are significant predictors of the brand. So that's all from me for prediction modeling.
In conclusion, this report has teach our group using a right way of dataset, and we choose 150 random data from 156 dataset in SPSS, and also 4 variables, which is liter per 100, KPL, weight, and brand to complete this report. SPSS data are used to measure mean, median, and mode for liter per 200. The results show mean at 6.39, median 6.75, and mode 5.72. This variable also used to measure of position and also measure of variation. Next, this report also include a histogram and Ogilvy graphical. This is important to person who analyzing data because it make more effective in comparing and understand data. Our group also use 2 different ways to measure numerical descriptive, which is liter per 100, it using SPSS software and manually. But value of this have a big difference because SPSS cannot read all data accurately. The ANOVA also being calculated in hypothesis testing. In other hand, the report shows an evidence of scatter plot regarding strong correlation between liter per 100 and weight, while in 95% and 99% confidence interval, mean result mean for weight is lower than liter per 100 at 0.16387 and 0.4317 respectively. Lastly, regarding coefficients, brand expected to decrease by 0.731 and provide other variable remain unchanged. I think that's all from me. Thank you.